Okay, this is AGEC 685, Module 1, Lecture 1, where we take a look at a programming problem. It's a farm management problem, but that's not really all that relevant. We are just going to use it to kind of learn our way through the information needed to set up a problem and to how to start doing analysis. One of the issues in a class like this where we do quantitative modeling, and for much of the class we're just going to get a solution and try to work our way backward, is training yourself to look at the numbers as they sort of come in and look at the organization of the problem and see what you can anticipate, because that'll make decomposition of a solution or analyzing or communicating about a solution so much easier and just make you a more powerful modeler, communicator, analyst, what have you. So we'll use, this is a course called Quantitative Methods 2, and our method is largely math programming, and that means we are thinking about planning problems and thinking about quantitative or mathematical ways of doing analysis. Now, typically, especially modern, when we hear the word programming, we think about writing code that tells the computer what to do, and that is not what we mean in the AGEC 685 or the managerial economics sort of terminology. This predates sort of computer algorithms and coding at the level and sort of consumer level that we see today. We're really talking about a program of allocations, a plan or a recipe or whatever. Sort of, these are the quantitative, take quantitative inputs, do the analysis, right, which is economics based, over the numbers, and here is sort of the solution or the program that comes out, the program of activities that should be followed. How do we convert resources to activities? And that gives you something. It gives you a model or a plan to analyze and to deconstruct for information content. By its very nature, taking these problems that are conducive to analysis are almost always sort of small or abstracted from sort of the real world models, the real world application. You're looking at a part of a production line, right? But we know that the full context is, source to sink, right? From the origin of the inputs and how they're acquired, and what kind of markets and limitations there exist there, all the way to how does this thing proceed through the value chain. So we're taking small pieces of this, so we always have to keep that in mind. But the goal is to come up with a model for this part, look at all the information, and look for key insights for management. So we would never say, I did this quantitative model, this is what we should follow. It may be the case that this is the right thing to do, but we would always want to put it in context, make our case, and of course have the analysis to back it up of the key interactions and how limiting are the assumptions or abstractions that had to be made to arrive at this program or this result. Okay, so I'm going to use the term program just to try to get us all thinking of it that way. It's, in terms of the history of it, it is preferred, or it was preferred, to the idea of solution, because solution makes it seem like you've solved someone's problem and you've told them what to do. A program, in this sense, I suppose, was viewed as more, this is sort of the recommendation based on this other information, this limited information we were able to get, right, or these sort of limiting assumptions, right? Maybe we're using average prices over a 3-month period when in fact we know that our program, our activities should be very sensitive to prices, and prices adjust, day to day, in a way that we would have to take account for. So, and that means that we're opening ourselves up. When we put a program together or a solution together, or a recommendation, how do the assumptions or the way we've modeled the interactions cause changes to the best plan? A good program and solution, as we work through this class, we'll see, includes sensitivity analysis, trying to get a handle on, if this is what we're saying is sort of the target, how often is it the target, right? How good a plan is this if there are small changes or large changes to sort of the underpinnings of that problem. And it's obviously just like anything else in business, management, your own life, there's no plans that are worth blindly following. Okay, and so I'm sliding down here to the bottom section. Let me change my pointer. So math programming is the general term that we are going to apply for all of the course. Okay, math programming can be thought to include both simulation, which was something you encountered in the first quantitative class in this curriculum. Simulation, but typically more leaning towards optimization. So we are putting together quantitative information and saying, here is an objective that should guide the decision making, and then everything follows through from that. And so we'll try to put that context in everything, but a general term is math programming. We are not doing any computer programming. The entire course is built using spreadsheets, so that's teaching coding, while it's great and powerful, is not something we do in this class. Extensive use of math programming. So in a later module, we'll actually, when we talk about some of the sort of array of problems that can be dealt with, we'll talk about how it gets used. And typically, we learn it on small toy models that we can, that we could solve without needing computational assistance, so that we can understand the benefits and the interactions and how to deconstruct and do analysis. But these things get used in some automated management contexts as well, airline scheduling, of course, being one of the big ones. So people put in their sort of best practices and decisions into a programming environment to come up with a program management that manages planes, routes, and where they're going to end up, and sort of that sort of scheduling. And then another way to think about it, especially these sort of toy or smaller type models, or even the model you do for whatever you do for your capstone project in this class, think of it as a laboratory. So it's a way to test alternative plans or procedures, to really sort of understand those. You understand the limitations of what quantitative information we have, and understand maybe how past decisions could have been improved, how future decisions should take account of information. Okay, so the way we're going to present this and work through this lecture is through a sample problem of a crop and livestock farm with a bunch of predetermined information that makes this simpler for us to introduce all the topics. The predetermined information we have is that this is an operation that raises crops, and it's going to feed and then market those crops through animals. Okay, so the feeding and marketing is part of this. So when we talk about going to market or earning revenues, it's going to be from the animals. So the crop output is already known, or we have like an estimate of the harvest based on what's already been planted, and so that's sort of predetermined information. Our options then are going to be, what animals are we going to stock and feed? So I guess we could think about either we're bringing these in on contract, or we're going to purchase some animals to feed. Not really important, but that's our it's really about what type of animals and what quantity. Our objective is going to be the highest return. So we are in this world where we know we're going to market with animals. We're going to use our resources, which is feed that we've produced, And so that's going to be the objective. The limitations: we can only feed the product we anticipate harvesting. We won't be buying anything. And then we have a limitation on operating capital. And then we have a question: do we have a problem yet that we can work on? Well, I mean, we could be descriptive, but we don't have any information yet that would be that let us do analysis. So we need to start working on information, going from descriptive to quantitative. So we need to pin this thing down numerically, and one way to do that would be to start with sort of the objective, right? We know we're going to be selling animals, so let's put dollars to those animal outputs. And we have profit margin for 3 options. These are the only 3 options we'll be considering: pigs, calf, and yearling. Okay, so here are the numbers per unit. Right? I haven't even given you the units yet, but and we'll talk about units in the lab this week. But suffice it to say, if you interact, or if you do the activity pigs, every unit of it you do gives you 320. Every unit of calf gives you 280, and every yearling unit gives you 140. I believe when you get to the lab, you'll see that this is actually selling a pen of 10 pigs, selling a single calf, and selling a single yearling. These numbers cover the revenue that we would get, and they also cover the cost side. So one of the things we'll discover as we work through this class is sort of the accounting is not something we're going to pay a lot of attention to. It's the ratios or the relative size of things that is going to be important. We'll assume we get all the accounting right. And so because I say these are profit margins, then it must be the case that this is some kind of net, and so there must be some cost information built in here. And if we were doing analysis, of course we would want to go back and know the exact construction of 320, 280, and 140. But for now we don't. Additional information we need. We know we have limitations, and so we need to know, before we can do anything, we need to know what rate of usage is there. So how do these different things, pigs, calves, and yearlings, how do they use up the resources of the farm or the feed that we've produced? If we just looked at this on an output basis, just these 3 numbers, and we had sort of that famous term all else equal from economics, we would say, well, we're pig farmers. It has the most earnings. But it's the case that all else is probably not equal, and we can expect that the usage rate for these different activities or these different options will also differ, and that gets us table 1. And so there is a notes page that has all the tables in case you wanted to cut and paste the numbers for some reason. This is because this in the PowerPoint, this is pasted in as a figure, or as a picture, sorry. So this is the per unit usage of farm resources. So if we look at this, we have our options, or we're going to call these activities, pigs, calf, yearling, across the top. And then we have our resources here, corn, hay, and capital. And then where they intersect, this is the actual usage per unit. If we make a unit of pigs, which I believe we'll see as a pen of 10 pigs, then each unit of that activity will use 100 units of corn. Each calf will use 60 units of corn. Each yearling 30 units of corn. So we have a basis now for comparison. So the core numbers, the sort of return for doing the pig activity or the calf activity doesn't mean a lot until we know how they're going to exhaust the limited resources or the scarcity of the farm. One thing to note here is we have pigs that use corn heavily and use hay not so much. Okay. And okay, so if we were to put the profit numbers in a proper context, then we might think about the profit margin per unit of each activity. Okay, so if we're thinking about corn, how does the pig return, right, the 320 per unit of pigs translate into corn, into valuing the corn? So each unit of corn is worth $3.20 or 3.20 if it's marketed through pigs. Each unit of corn is worth 4.67 if we market all of the corn through calves. and the same thing for yearlings. Okay, and so if you want to see where I got these numbers, I'm going to swap out over to my spreadsheet, and you have this spreadsheet. And if you go to the first sheet, it's called data.m1, and this accompanies the lecture. You'll see here we have a table that shows all the usage rates that we saw in table 1. And then here we have a calculation. We're going to calculate the profit per unit. Okay, and so up here at the top, the pigs, calf, and yearling are the columns, corn, hay, and capital are the rows. And if you highlight this, you'll see that I'm just dividing B2, the profit margin per pigs, divided by B5, the usage rate of here of corn. Okay, and so 320 divided by 100 every time we use up pigs. That's how we're drawing down on the resource. Okay, so let's go back to the slideshow. And so how to choose? So pigs are if we wanted to compare these, then we can compare them through the row, right? So how do we use capital? Well, we're getting 10.67 per unit of capital versus 4.67 versus 0.58. So pigs are the best use of capital. They don't use any hay, so we really can't compare it. And then we see up here, calves and yearlings are the most profitable uses of corn. So now we have some context, right, on how to compare these things, how to put these things in a relative sense, right? So if we look at a single row, we can say that calves or yearlings are preferred to pigs if that row or that thing we are focused on is corn. If capital is where our focus is, then pigs are preferred to yearlings and calves. But we still don't have a basis for a program for this farm. We know how to use the resources, but the farm has an assembly of resources, a package of resources. We don't know which one is actually scarce for the farm yet. And so that gets us to our next piece of analysis, and where we're going to try to put those that context into an appropriate one that thinks about the farm's actual problem with the limitations. The one thing we know, though, there are two possibilities. One will either be specialized, and that means the resource situation of the farm, will dictate that we just focus on the highest return. Okay, when does that occur? If the same resource is limiting across the entire farm, right, for every activity, for every option we have, then yeah, we want to specialize. But if not, if there's some resource situation, right, where some things are limiting for one activity and something else is limiting for another, then we'll want to produce a mix. Okay, but for now, the two generic options are whether it be specialized, making one thing, or the product mix, some mix of these three. Okay, or two of the three, however you want to think about it. Okay, and so now we need to add some numbers to get an idea of the scarcity of the farm. So we have units of corn, units of hay, and units of capital. Okay, I'm not actually saying what these units are, but just take them to be 2,400 units of corn. Okay, and so we have these, and now we know hay is the smallest numerically, but we need a way to convert it. We don't have a context for that number either, right? We don't know, is 100 units of hay a lot or a little compared to 2,400 units of corn? That's something we can't do, but economics gives us this natural bridge. Because we're talking about converting resources to products that go to market, that's the translation factor, the Rosetta Stone for all of this. And so let's think about a way to compare resource rates and scarce resources. So, and the way I've done that is to calculate what I call the maximum activity level or output level by each resource. Okay, and so this says that for pigs, based on the corn available, I could make 24 units of pigs. Based on the corn available, I could make a maximum of 40 calves or sell a maximum of 80 yearlings. Okay, and if you move down, you'll see that we have calculations for hay and capital as well. So I have enough capital to do 540 pens of pigs, only 33.7 pens of calves. Okay, so let me pop back over to the spreadsheet so we can see how table 3 was calculated. And you see it down here, F5. Oh, okay, yeah, here. The total available on the farm, 2,400 divided by B5, the usage rate. Okay, so 2,400 total units of corn divided by the 100 units every pig production activity. Every time we decide to add a pen of pigs, we're going to use up 100 units of corn, and that's the division that we need. And then the division is the same, right? So 2,400 divided by 60 would be the formula that sits here, F5 divided by C5. And then here, we're going to have F5 divided by D5. And that's where these values come from, okay? So 2,400, 100, and then just keep moving down, and 16,200 are the divisions that get done here. 16,200 divided by 30. So when you get that result, these numbers, or back into the PowerPoint slides, these numbers in table 3, they give you a picture of what options do we have in terms of upper bounds. And so there are two ways to think of these numbers. One is the maximum activity level that can be produced given the resources on the farm, or you could think of it as the most limiting resource for each activity. So in the first one here, well, either way, right? So think about a focus now on, we were focused in the last table 2 on, let's look at the row for capital and think about comparing pigs versus calves versus yearlings. Now let's look down each column and say, let's compare the maximum amount of pigs that can be produced given our corn, hay, and then capital. And really the only one of interest is the one that's the smallest, right? Because these are you can't get the smallest of these maximums is the actual maximum for the farm. So we know that even in a specialized solution, if we only make pigs, 24 will be the limit on the number of pigs, pens of pigs that we can make. For calves, the lowest number is capital. 33.75 would be the limit, the most calves that we could sell. And for yearlings, it's corn. Okay, so for 2 items, corn is the limiting factor, and for 1 item, capital is the limiting factor. So, and that's what I've reported down here. So we have different limiting factors for different activities. That's a situation that tends to lead itself to non-specialized solutions or product mixes, right? So you're trying to find the best mix that will use these 2 factors, corn and capital, that are limiting for certain activities to come to a solution. Okay, so the calculations we have done show that 2 resources can be considered most limiting. It just depends on which activity you have in mind. If the same limit, so here's a key point, you'll see it again in your quiz. If the same factor is the most limiting for every possible activity, for every profitable activity that we can do, then the analysis goes all the way back to the beginning where we said pigs have the highest per unit return. Because if the same thing is most limiting for everything, right? If we only have 1 acre of land and lots of fertilizer and lots of machinery time and lots of fuel, then we probably just want to put that whatever crop on that 1 acre is the most valuable, right? Or in this case, if corn or capital was very limiting, we would want to focus on it's so limiting that it was the most limiting for every activity. We would want to focus on that. Yeah, so specialization occurs when the same factor is most limiting across all the activities. Something else we would do. Think about a specialized program and then examine the unused resources. So if it were the case, right, that we had some kind of solution where we'd specialize in pigs, for example, capital is most limiting, or if capital had been most limiting for every activity we had, then we know that the best use of capital is in pigs, and that would be a specialized solution. But pigs don't use any hay, and we already grew that hay. So we would want to think about expanding our problem from that point, right? Instead of saying we make hay and we let it sit because we are specialized pigs and pig producers or pig marketers, we would need to add an activity to our program. And the easiest one to do would be we sell our hay directly to the market because somebody out there can use it, right? It should have some value. And so that's sort of an expanded step that we might make. What do we want to get across here? This idea that most limiting is going to play a key role in determining our solution, whether it's specialized or product mix. And we are also going to go back at the end of our program and look at what resources weren't limiting, which ones do we have excess of, and is that a structural issue that we should continue and expand our model for, and think about how do we convert those to value, or is it something that we just think about in some other context? Is there an acquisition or a procurement issue that we should be dealing with? Okay, so what I can tell you, we have multiple limiting factors. We do not have a specialization solution here. And so what I want you to think about is, how would you solve this? Okay, some of you probably have already had a class like this where you use Solver and you know how to set it up and solve it. I don't want us to do that yet. I want you to think it through. Think about the Table 1, Table 2, Table 3 information that we have in this lecture, and think about how you would go about it, algorithmically or just step by step. What steps would you take to come up with the most profitable plan given the information that was there? Not cheating and making any new assumptions or anything like that. Just go through it and think about how you might do it. Even write it down for yourself, a little candidate solution. And then we are going to proceed and continue working through that and think about it in Lab 1. But your next step is to take Quiz 1, which is just a Lecture 1 review. It hits on some key highlights and some questions that you might consider. And then move on to Lab 1, which has a handout and where we're going to look at setting up an analysis of this problem, both sort of in an algebraic context and putting it in Excel.